this is Mark, and I'm giving a video of my homework 9. Before that, I'll just show you my room to ensure that there's no cheat sheets. Here's my formula sheet and constant sheet of O. Everything on my table. This is a baguette I'm gonna eat later. Here I have the problem statement. So let's get started. First, right off the bat, this graph is a bit tricky. You can see there's the isothermal process, isochoric process, and a diabatic process. For isothermal, we know that PV equals to PV after, but couldn't do much with this. For a diabatic, we know IV to the power of gamma equals IP PV to the gamma power of gamma final. Of course, these are still not very helpful to the problem we're doing, and we just gotta keep going downward. What happens if we keep going down? Well, we know there's the isochoric process, and during this process, heat must have lost from the system. Yeah, from the engine. That's a better word. So heat must have gone out from that part. What this means is we can find Q out, and Q out equals to NC. Well, since they have the same volume but different pressure, we use CV delta T. We don't really know what T is, but we don't really know what T is on the graph, but we know T equals to PV divided by NR. So we got that Q out equals to CV divided by R times delta PV. Oh, actually, sorry, my mistake. I wasn't given P and V, but I was just straight up given the isochoric process Q out, the temperature change. So we can just say that NCV equals to, I'm gonna cross this out, 250 mole times 3 divided by 2R times, since, well, it's a monoatomic gas, negative 300K equals to 250 times 3 divided by 2 times 300 is negative 112.5 kJ released. Here we can find the released amount, but of course, when we're doing the actual calculation with this whole thing, it's not going to be the released amount. It's not going to be a negative amount. That doesn't quite make sense. E equals 0.3. We also know it equals to 1 minus Q in divided by Q out divided by Q in. So we get 1 minus 102.5 Q in equals to 0.3. Solving for the function, we will get Q in equals to 160.7 kilojoule. Here's what we found for the Q in. Keep going forward. We will go into studying work is simply Q in minus Q out, right? It's Q in minus Q out equals to 160.7 minus, again, we will take away the negative part because obviously don't make like conceptual sense. We get that 48.2 kilojoule of work done. And remember, this is a work done in total by work output of the engine. It's not a work done on the thing itself. How to find that? Well, we know that work actual, this is work total. Work done equals to F times change in distance, FD, or in the calculus way of saying it by integral, it's FDY. FDY, here we know instead of the equation, F is gravity minus the buoyancy. Mg minus buoyancy is rho v g d. Let me see if I have buoyancy. V displaced dy. Now we could see that here's the equation we're going to use, but of course this doesn't have a y component here, which is the changing part. So we need to dissect what's in the variable b. By opening it up, we can set it up as a times a, which is the bottom area, times the height, and the height is the changing part. It start with 3.5. Sorry, start is 4. It gradually move up as we go do work with the distance. How does that work? We will keep moving till it hits the top. So it's 4.0 mg minus rho a g 4 minus y dy equals to, and then we just solve our integral. 0.4 mass of the total stick, well, I don't know, if it's a cylinder probably, times 10 to the 3 times 9.1 minus 1030 times 1.5 times 9.1 times 4 minus x. X is, okay, something is off with my input. Don't worry, I'm gonna find it out. Okay, maybe if I okay, so it's 114.2 kJ. The problem is this is different from what I got from above. Well, what if something's off? Okay, maybe I got the Q out wrong. Well, no, the equation is right. Okay, this is confusing. It's isochoric, right? It is isochoric. So, 250 times 2 times 9.1 times 300. Oh, okay. Oh, I didn't add R. Okay. Okay, so turns out I forgot to add the R component into the CV, and QL calculation is wrong. QL is actually minus 1103.6 kJ. I guess Q in would be, yeah, this is my bad. 1103.86. Fuck, let's just keep going with the number. Okay, I got 400 something, but I don't feel like that should be the answer. Now I'm saying this because I've done this beforehand and checked those things. I got a different number. What in God's world am I doing wrong? Oh, okay. Yes, the gas constant is 8.31. Okay, I've been putting 9.81, the gravity constant in there, so it's a constant. Okay, if I change the constant up, it should be negative 934.9 kJ, and this one should be this is more like 1335.6 kJ. What total is? Okay, yeah. This is right. So here it actually should be 934.9, and down here it should be 1,335.6. The difference between these two, Q in, Q out, is the work in total done. It's 400.7. And the actual work that's done to the cylinder, it's 114.8. And then finally, the percentage lost equals to 1 minus work done divided by work T equals to 1 minus 100.48 kJ, 100.7 kJ equals to 71.4%. There's a little bit of margin of error, but here's my answer. Box up. 71.4% of the work done is lost to imperfection. That will be it. Thank you.